Okay, guys, so we're modeling 12 and 15. Yeah, whatever. It's the day of prom, in the morning of prom. That's the day it is.
Oh, what do you want, maybe?
I can come to school, take the test, and then leave?
Yeah. Remember, Alex, you can come to school and leave anytime you want, any day you want. So feel free to do that. No one's gonna stop you. But
I need to.
all right, so guys, let's come back together. Then tomorrow, guys, so tomorrow we will go over the common mistakes on the quiz that you turned in this morning. So I'll have those graded by tomorrow, as well as the problems that you'll turn in today at the end of, today. Then you'll have the rest of the time to work on this. And then tomorrow you'll get the take-home quiz on the 2 sample intervals, which is what you're handing in the homework today. Friday I'll teach something new that will not be on the exam. Monday's the exam, and then Tuesday we'll start the next. Yeah, I'll teach 2 days after the exam, and then we'll review for the common assessment. No, because we have to, or we can do the exam on. This is the review. So if you do this, you'll be totally fine for the exam. So let's get started. So number 12, we are conducting a hypothesis. Are we recording over there? We are conducting a hypothesis test, and we find that the null hypothesis. So number 12, the null hypothesis is that mu equals 0, and the alternative is mu does not equal 0. And we also find the p-value is 0.0675. And the question is, if we create a 95% two-sided confidence interval, two-sided just means plus minus, so you have two-sided confidence interval is like x bar plus or minus the margin of error. Two-sided because you got the plus side and you got the minus side. So we're saying if we were to construct one of these with a CL of 95%, will it contain 0, yes or no? Will it contain 0, yes or no? So let's think about this. So we constructed a 95% confidence interval, and the question is, oh sorry, it's on the chair, Khadija. Yeah, will it contain 0 or not? If we think about it, let's go ahead and draw a little picture. So here's some kind of distribution, and we got some interval. We have no idea where it is. All we know is that within the interval, we've got 0.95 or 95% of the data. That's all we know. And we also know that when we did the test, we got a p-value of 0.0675, which means the probability of getting 0 if the null hypothesis is true is 6.75%. So the question is 0 in here or is it out here? And the way we will attack this is the following. If 0 was in one of the green spots, the probability of getting 0 would be at a maximum 5%. Couldn't be more than 5%. Because 95% is here, so if it's on one of the tails, the maximum it could be is 5%. We already know the probability is 6.75%. So 0 must be inside here. Because if it were outside, then it would have a probability of below 5%. The probability here is above 5%. Therefore, 0 must be inside. Alex, question. You sure? Questions on this? This requires some, yeah. So the answer is yes, 0 must be within the 95% interval, because if 0 were not, the probability would have to be below 5%. Has to be. Because only 5% of the data is left. Alex.
Is it 5% because it's 2.5 on each side?
Yeah. So that's what I'm saying. So maximum 5%, right? But yeah, you're certainly correct. There is only 2.5% percent on either side. But the absolute maximum, even if you forgot about the two-sided interval, right, would be 5%. Now, what about a 93% confidence interval? Does that have 0? Let's look. So we come here again, and we have this interval. This time in here, we have 0.93. So, is 0 going to be here or not? Well, if 0 were not inside here, let me say it this way. If 0 is inside of here, right, then the probability is lowest 7%. Right? If 0 is in here, all we've got left out here is 7%. Jennifer.
Are you still using the same p-value?
Yeah, exactly. So here, right, the probability of getting a 0 is below 7%, so it must be outside the interval. If the probability, in other words, if the p-value is less than what is left over, 0 must be inside. If the p-value, let me say it a different way. If the p-value is bigger than what is left over, here what's left over, 5%, p-value is 6.75, 0 must be inside here. Here the p-value is 0.0675, 6.75%. What's left over here? 7%. 0 can't be inside. That's all we wanted to get across. So the key is, if the probability is more than what is left, we have to be inside. That's it. And that should make like logical sense from the picture. Questions on that? If we create a 94% confidence interval, will it have 0? Well, if we have a 94% confidence interval, 6% is left. The probability of 0 is more than 6%, so yes, 94% interval will have 0 in it. That's all we want. So questions on that? Cool. All right, and number 15. So 15 is an interesting question, right? So when finding a 99% confidence, when finding the 99% confidence level for the proportion of people who enjoy this ice cream, we found that the proportion was, that the interval was this. And the question is, what is the sample size? And so this is a doable problem, but it kind of requires some sort of outside the box thinking. So because this is a proportion, we know we have used a z interval. And we know we have a one sample, because I'm only seeing the people who enjoy chocolate ice cream. So it's a one sample. One sample z interval. So if I'm using a one sample z interval, I know the formula for the margin of error. The formula for this is this times square root of p q over n. And that must equal 0.421. Because that is the margin of error. So now we just need to plug in and solve for n. So this is the key insight that it took me a little bit to catch on last night when I made this problem. How do I know what this is? That's the money question. How do you know what this is?
The confidence interval is plus or minus the margin of error.
Right. So what is this going to be?
137.
Yeah. This is 0.37. That is the p-value. Because remember, the confidence interval formula is p hat plus or minus this. So we need to take the 0.37 and bring it here. And then we know how to find q. Remember, q is just 1 minus p. So we can write our equation as the following. 0.421 equals, we haven't found the z star yet, we'll do that here in a second, times square root of 0.37 times 1 minus 0.37 all over n. Now we need to find z star, that is to say the critical value. So let's go to our chart. Okay, so we go to our chart, and we care about z, so let's go to the z page. And they said a 99% confidence interval, which remember, we want a 99% confidence interval. Here's the picture. So here's 99% of the data, but remember, go ahead, Alex.
Can you go back to how did you determine that 0.421 was your margin of error?
Yes, give me 1 second, I will go back there. So we know that we want 0.99, but remember on the z table, it only calculates from here all the way to the beginning. So how much area is from here all the way to the end? Well, 0.99 plus this maroon piece. How much is the maroon piece? 0.05. So we need to find the z-score that goes with 0.995. Please make sure this logic makes sense. Because remember, on the exam, you won't have your, like, where you've already, like, written down the, like, 95% and stuff. You'll have to actually dig it up from here. So understand how this happens, please. And then we're going to get to Alex's question here in a sec. Are there any questions on this, since we've already got the picture here? Okay. So, Alex, to your point, the confidence interval formula is p hat plus or minus the margin of error. So the 0.421 is the margin of error. Does that make sense, Alex?
Yeah.
You good? Okay. So now we go back to here, and we need to find 0.995. So that is over here at 2.58 is what I got. Make sure you can get that, 2.58. So now you just want to plug in 2.58 right here. 0.421 equals 2.58 times square root 0.37. 1 minus 0.37 is 0.63. All divided by n. Remember, the n is also under the radical. And now we need to solve this out. So now we're at algebra. Step 1, divide by 2.58 on both sides. Who does not have a calculator that is working today? If not, just please leave the numeric card out, right? Because we set that expectation on Monday. So just go ahead and divide by 2.58 on both sides. So you'll get, let me go to a new page here. So we have 0.421 divided by 2.58. And then we've got 0.37, 0.63 over n. You want to square both sides now? To get rid of the square root here. So you've got 0.421 over 2.58. The whole thing squared, and that's equal to 0.37. 0.37 times 0.63, all divided by n. So let's plug that in. So 0.421 divided by 2.58 squared gives me 0.026627. 0.026627 equals 0.37 times 0.63 all over n. This is a fraction equal to a fraction, so you cross multiply here. So this times this equals this times this. Again, if the algebra is going too fast, please stop me. So you cross multiply, leaving you with 0.026627n equals 0.37 times 0.63, 0.2331. Divide both sides by 0.026627. What do you get?
8.75, 4.6.
Really? It's that small?
Yeah.
So clearly I sampled 8.74 people. Call it 9 people. There you go. My hope was that I would have sampled more, but you know, maybe I was low on money. Think back to the free response problem about the car company had only $12,000, right? Okay, so that's what we want you to get, folks. So you're gonna have to do problems like these two on Monday. Victoria.
We do get an equation sheet, right?
Yeah, and big news. We're having the equation sheets laminated at a significant expense to the school, but they're willing to undertake it because they care deeply about your futures. No, but then you'll have your own personalized one that's laminated. For each person at a huge expense to the school. Initially, they didn't want to do it, and I pulled out my wallet. I was like, here's the money. They're like, we don't want to take your money. We'll do it. It was a big scene. I wish I should have recorded it. It would have been nice. Okay, turn this off earlier. We're done with this.